Okay, so y equals 6 to the x. The first question that it asks you here, is it growth or decay? And there's, are you allowed to use your graphing calculator on this?
Yes, we are.
Okay, I would probably, I mean, there's a bunch of different rules. I would tell you to graph this with your calculator immediately. You will see that it looks something like this, but that gives you the answer right away, rather than us going through like, okay, well, is the number less than 1, bigger than 1, positive, negative, fractions, exponent, positive, negative. There's a lot of rules.
Yeah.
And it's a lot to remember. So you don't have to graph that right now, but that would be my recommendation for that. So that's part A. Part B, go ahead.
Yeah.
So now the next question asks for, it says, what is the asymptote? It's actually referring to the horizontal asymptote. These only have a horizontal asymptote for exponentials, and it's whatever number is being added over here to the right, which you can see I've added in a 0. So this one is y equals 0 for that.
Yeah.
Now this C and D is actually somewhat new to me. This H comma K stuff, that's usually refers to the vertex, but it could be referring to kind of this like centering point. So how do I want to say this? Oh boy. I've actually never seen this in this context before. Do you have the answers to know what I mean, so H is probably 0, but do you have the answers here for the instructor, what they're referring to?
So he gave us the equation. It's like y equals a, and then it's like
X minus H.
Yeah, and then plus K.
Plus K, yeah, that's what I was thinking.
And then
Okay.
he was like, just plug it in to find which one was H and K.
So H represents the horizontal shift, and that's always going to be in the exponent. Basically, you're looking up here at this x, and it's like, well, is it x minus 2, x plus 1, x minus 3, x plus 4? You're just looking up here to see, like, is there anything going on? And in this case, it's 0.
Yeah.
Now K is actually related to what we did in B. Sorry, just trying to get this thing to come down. So K is it's the vertical shift in some ways. We'll say that in quotes, but it's in your problem here, it's 0 because there's nothing being added to the function.
Yeah.
The domain for all of these is always all real numbers, or minus infinity to infinity. For all of them, all will be like that. The range depends on a couple of things. Looks like all of yours are going to be, so this is a simplification, but all of your ranges are going to be from K to positive infinity.
Right. Okay.
All right, so that takes care of everything for number 1. We should do number 2 because it's slightly different, but it doesn't have all the features in it, but like, I guess that's okay. Yeah, I guess we'll do number 2. Any questions on number 1? Oh, and you do need to make a graph, but you'll have your calculator. I would just use the calculator graph as best you can.
Yeah, I just tried to do, I don't know why, maybe something's wrong with my calculator, but
okay, let me jump in and make sure I can help you with that. So let me grab my let's see here, where did it go? There it is. All right, so let me new share with a calculator with you like this. So the way you graph this is you type in 6 and then the caret button X or exponent X like that. And when you go to graph, if you haven't graphed in a while, it's probably a good idea to go to Zoom Standard or Zoom 6. That'll get you back to the base window. And you should see something like this. Is this at all appearing on your screen?
I saw that one because I did this like in class and it was working, but now whenever I press graph, it says like quit or something like that.
Okay, so one of the solutions is to always go to second mem down here and to basically reset. Now you got to be careful with that, obviously, because anything you've got saved on there will go away. But that would be your path to sort of get everything back to normal without me being able to look at it and see. Now, if you don't want to do that, that's fine. You'll just have to ask someone, maybe ask the teacher in class, but that would be my recommendation. I'm sorry, I can't.
Second, and then what do I press?
Mem, which is under the plus.
Oh, okay.
And then you go down to 7 to reset everything.
Okay.
I think it asks you one more prompt after that. Let's do it. Yeah. All RAM, yes. And then yet another.
Yeah.
So believe it or not, I had a teacher in high school that would walk around and do this for every student before the test.
Oh, wow.
Yeah, they were very, very skeptical of students, and rightly so. But I, now you're more worried about a phone than a calculator. But so hopefully now, and you'll see everything's deleted.
It's working. Yeah,
it's working, and that's kind of your like. I mean, hopefully you don't ever do that on your phone when you're reset all. But
I know. Gosh.
that's some people do that. So that like we can get into the graphing, but I really want to maximize what we get done today. So I can just leave it like that and go back and talk about number 2. Actually, let's graph number 2 since we're already on the calculator there. So go back to y equals, and you'll see it's in parentheses. So it's 1. Actually, you want to put it in parentheses. Here's 1/5 caret, and then mine, because I don't have any special features, I have to do the parentheses as an I'm sorry, I have to do the exponent in parentheses like that.
Yeah.
And then you graph.
Yeah, that's what I got.
Perfect. So notice this one's DK, and that's probably the best way for you to do it rather than learning a bunch of rules. You can also get the graph going as well. So let me go back to the other screen. And so A is DK. B is what is the asymptote? So there's no number being added over here, and that's your K now. So it's y equals 0. Your H is 2 this time. It's 2 because you said x minus 2 equal to 0. And well, that's one way to do it. But it's right too. This is how I do it. But your instructor said to line it up. That's maybe the best way for you to be consistent with class.
Yeah.
D is to find the value of K. That comes from B, so K is 0. E, the domain is minus infinity to infinity for all of these. And for F, the range is always from whatever K value you have to positive infinity. So your K value is 0, so it's 0 to positive infinity.
Yeah.
Okay, let's do 3, but not 4. Any questions on the last one before we move to 3?
No, I think we're good.
Got it. Okay. All right. So for this one here, you would find that it is growth by graphing it. Are you familiar with where the E is on your calculator?
Yes.
Great. So now part B is to determine the asymptote. So we finally have one here. It's y equals -1.
Yeah.
C is what is the value of H? So this one's different though, because it's, this is where, it's like, well, it's x minus h like this. Maybe it's clear to you, but there's really a -0 there in the exponent. So that is
Right.
your h value. Your h ends up being 0.
Mm-hmm.
There are other ways to do it, but this is what we'll go with. D is the value of k that comes from b. K equals -1. The domain is still all real numbers, -infinity to infinity. The range goes from k to infinity. Again, that's a simplification, but
Okay.
all right. So you said 5 through 12. Are there some here for sure you want us to look at?
Let me see. So probably 11.
Okay. Start with that and see how it goes. I can always give you some like it, like the ones, just to see if there's understanding.
Yeah.
All right. So what I'm seeing here is I see there's numbers. There's 2 and -4. Those can be multiplied together.
Mm-hmm.
And then I see a bunch of things with e. I see e to the x, e to the 3x minus 1, and e to the 6. So this is just a rewrite step, or really it's rearranging.
Yeah.
Okay, and it may be good to do if you can't do it visually. 2 times -4 is -8. Now, these 3 here, the rule is if the bases are the same, which they are, they're e, and you're multiplying, which is what is implied here, then you add the exponents. So rather than try to like figure out what it becomes, just write it as if you're adding, but don't simplify. And then from here, you just combine like terms.
Okay.
So it's like, all right, I got an x and a 3x, that's 4x, a -1 and a 6, that's -5. And then I bring that -8 down. Would you
Wait,
like
so
one?
x plus 3x is 4x.
Yes.
Oh, okay, then
Oh,
-5.
I'm sorry. It's and then +5. I got a sign error there.
Yeah. Okay. And then, so 7 would be kind of like the exact same thing.
It's a simplified version of 11.
Yeah. Okay.
I'm curious if 8 was clear to you, or if you.
Yes, so isn't that you just take the 5th root of 32, which is 2,
Yes.
and then don't you just divide 15 by 5?
Yes.
Okay, so it'd be 2e to the 3x.
Yes.
Okay.
Good. 6 is like 7 and 11, but uses the division property.
Yeah, so that one, can you do that one actually?
Of course. And if you want one like any of these, just let me know. I'm happy to create one.
Okay.
Yeah, so this is kind of a mixture of a couple of rules. The one that we were doing in the previous problem is when the bases are the same, you add the exponents. But when you're dividing and the bases are the same, you subtract the exponents.
Oh, okay.
And you need to know both here. There's also kind of a, you can do them in either order. Like there's no order of operations here. So like I would probably tell you like, okay, let's look at the top first, and then we'll deal with the bottom. So just rewriting it, it's -3 e to the 4th, e to the -3 like this. So that's where when the bases are the same and the top, just the top here, and you're multiplying, you add the exponents. So it becomes -3 e to the 4 plus -3.
Right.
over e to the minus 2. So that 4 plus minus 3 is e to the 1. E to the minus 2. So now you subtract the exponents. It's minus 3e to the 1 minus a minus 2. So this is the one I think is most unclear for students. For some reason, you forget to add a subtraction symbol when there's a negative on the bottom. Just write it out. And then you got to be able to simplify here. So minus 3e to the third.
Okay. Yeah. All right, that makes sense.
Would you like one like any of the ones that we've been working through here? Or do you have any questions on the logarithms?
Maybe something like number 11 or like 7, something like that.
Okay. All right, so let's give you an example or try it out. Okay. Okay, yeah, you guys are using e. All right, e to the 2x times 3e to the x plus 1. And I'll just throw in a little wrinkle here, e to the power of 2, like that.
So so far I have 3e to the 3x plus 1.
Very good.
And then over e squared. And then you subtract 1 from 2.
So what's best to do is just write it and not try to like evaluate it in the same step.
Okay.
It takes one extra line of writing, but it likely prevents like sign errors and like calculation errors and all that stuff.
So it'd be -1.
Yes, 3e to the 3x minus 1.
Oh, so you just flip the, okay. Yeah. Okay.
Any questions on that?
No, I think we're good.
All right, so you said transformation problems like 30 and 31 to look at.
Yes.
Now it would appear there's like a whole page that we have not looked at that could be on the test of questions. Everything in between these is okay.
Yeah.
All right.
Actually, let me see. Well,
If you need to, just send it over and we'll look at it.
yeah.
All right, so just a minor thing here. The formatting of this is just a little bit, I would say a little bit off here just because of the spacing, but you really kind of want to identify the parent function here, which is 3 to the x. And what that does is it kind of tells you what it is that you're also looking for that are transformations. So like what I see is this is a transformation, that negative in front. This 2 in front is a transformation. And then the +2 to the right, this is also a transformation like that. So there's 3 transformations here. Now the order does matter, but sometimes instructors don't prioritize that. They just hope that you get them correct here. Do any of these like mean anything to you? Like the negative in front, the 2 in front, or the +2? Meaning like, do you know any of the transformations right now?
So it would be a reflect in X, like the negative would be.
Yeah, so we'll say reflect over the x-axis. Some are very particular about the language.
Mhm.
Like thou shalt say this, be very careful. Just use the language they have in class.
Yeah. Up to for the,
Yep, up to.
and then vertical stretch of 2.
Yeah,
Is that because it's in front of the 3x?
yes.
So if there wasn't a times 3x, it was just like -2 and then something plus 2, it wouldn't be.
So let me write out the question I think you're asking me, because I want to be just because I can't, we're not right there. Here's
Yeah.
what I heard. So for this problem,
Yeah.
this is your parent function right here.
Okay.
So there are actually only 2 transformations.
So it'd be reflect over the x axis and then up 3.
Yes.
Okay.
But of course, there are other ones here. So let me get into a few of those. Let's go y equals 5 to the x plus 1, negative -4. So this one has 3 transformations.
So it would be reflect over x axis
Yes.
and then down 4.
Yep, down 4. And actually, I got the order wrong here. What about that plus 1?
It'd be left 1, right? Because you have to
Yes.
switch the signs.
Yes. And the order does matter. But, so what would the value of h be in this one? This is kind of your parent graph here.
So it would be 1, or would it be negative?
So it comes from sometimes it's better, like the left one is -1. And that's yeah. So it's sometimes it's hard to explain. It is opposite in sign. Left one means -1 in this case.
So it's always going to be the opposite sign for h.
Yes. Yes.
Okay. Okay. Can you do 31?
Yes.
That one looks a little bit more.
Well, 31's completely different. So it's like like you learn everything for 30 and now it's a whole different set of rules. If it hasn't been made clear in this part of the course, you're either doing exponential problems or you're doing logarithmic problems. And there's a lot of properties that are sort of like they sort of like flip.
Right.
So they're related, but like it's almost like you've got to know which path you're going down to be able to answer these questions.
Mhm.
Okay. Let me give you the transformations of this one just to see how consistent it is with what you're seeing in class. So the only one that probably is clear is up 3. But the first one here that I would say is a reflect over the y-axis. And that's from this negative inside parentheses. That's kind of a key difference.
Okay. So what if it wasn't in parentheses?
Like if the negative was out in front,
Yeah.
that would be x-axis.
Okay.
Okay, now the two is where it gets a little bit complicated. It's a horizontal, and then I got to be careful with the words here. I don't know how much, so there's the language here is really bad in most classrooms. So if the number is bigger than 1 on the outside, it's a stretch. But if it's bigger than 1 on the inside, it's a compress.
Okay.
but I don't know if you're using that language because some structures just allow you to say horizontal stretch factor of 2. It's not really 2, but like, do you know what is approved in your class?
Yeah, we just say horizontal stretch of 2 or like horizontal shrink of 1/2.
Okay, and let's go with that.
Okay.
So do you have that down? Is that all clear?
Yeah, can we do more of the
Yeah.
transformations?
Yeah, I just want to make sure you got that one down. We'll do one
Yeah.
like it here.
Yeah.
Let's go y equals 2 log base 3 minus x plus 1. So this has 1, 2, 3 transformations.
Okay, so I know up 1.
Okay,
Reflect in y,
that's right.
and then horizontal stretch of 2.
So this one's actually on the outside. I was putting a little wrinkle in this one. This is a
Mhm.
vertical stretch.
So if it's in the parentheses, it's horizontal.
Yes.
Or if it's behind, yeah, okay,
If it's in parentheses, it's horizontal.
gotcha.
Okay, so now let's look at another one here. Let's go y equals log base 5x minus 3. This has 2 transformations. Actually, let me add one more here. This one has 3 now.
So down 3. Horizontal horizontal stretch of 5 or 1. No, wait.
Of 5. Of
Yeah,
5.
5.
Yeah. Yeah. It actually goes up here. Okay. And then what about this negative out in front?
It's reflect in x, right?
Yes.
Yeah. So if it's always going to be reflect in the y-axis in the parentheses with.
Yes.
Okay.
Okay. So here's another one here. So this one has 3 transformations.
So right 2,
Yes.
and then vertical stretch of 3.
Okay.
And then reflect in x over x-axis.
Good.
So how do I not get confused with x-axis and y-axis in this one?
So well, the answer is hang on just a second here. Okay, so you're asking a really good question because you're like, well, that's great in these problems, but how do I remember it more generally? So if it's inside parentheses, like let's say there's a negative there, that means it's the y-axis. Let's say there's a number there. That's a horizontal. And let's say there's like a x minus a number. This is a shift left or right. So basically everything inside parentheses has to do with like horizontal stuff. The only exception is like the y-axis is vertical, but maybe you still see that as being part of it.
Yeah.
Outside the parentheses is all the other way. So here's your parentheses. If you put a negative here, that means that means it's x-axis. If you put a number here, it's a vertical stretch. This is a stretch. And then if you add or subtract a number here on the right, that's up or down. Is this sufficient, or do you feel like there's still gaps between what you think you know and what you need to know to get?
I feel like it's definitely better. I just need to get it like in my head and get used to it.
Here's another thing that I used to do. You can go to your calculator
Mhm.
and you can graph log x and then log minus x in y1 and y2. And for example, log x will look like this. And then the second one will reflect over the y-axis, so it'll look like that on the same graph. And that maybe will help you if you're not sure. But you only want to graph like one at a time. So it'd be like, what is like e to the x versus minus e to the x. So e to the x looks like this, and then e to the minus x looks like this.
Right.
And that could help you if you're really, because they're binary. It's like heads, tails, you know, it could go either way.
Yeah.
Just you know, easy to misremember.
Yeah, because because the log and then the x parentheses is it goes over the x-axis.
Right. So like again, like you could say, okay, what is log of x minus 2 log of x plus 2? And one moves it right and one moves it left, and you'll see that.
Yeah. Yeah.
All right. What else can we cover here? Just some graphing of logs.
Yeah, probably that bottom part, like the 44 through 47.
Okay. All right, so the one of the things here though that maybe isn't made clear, if you were to graph this, you have to close parentheses around the x like this. Otherwise, it'll graph something different than what you think you should see.
Yeah.
All right, so now let's go through the questions here. A little bit different than you know, growth or decay. The first question here asks about the asymptote. So this one's different. This only has a vertical asymptote. And what you do is you set the inside the inside parentheses part equal to 0. So here you set this x equal to 0. Now sometimes you have to solve it, but this one there's nothing to solve. That is your vertical asymptote.
Yeah.
You know what? I may be wrong. Your instructor may have meant x plus 3. I really can't tell now that I'm looking at this again.
I feel like it looks like x plus 3.
Inside parentheses.
Yeah, probably.
Yeah. So that would change this. That would change it to x plus 3 equals 0. And then you subtract 3 from both sides and you get x equals minus 3.
Okay. So that's the
Yeah, that's the asymptote. It's always vertical. So that leads you to B. B is the asymptote is the H value. So the H value is this number right here. So it's kind of like the exponential ones here. If it's truly natural log x plus 3, it's natural log x minus h. And we talked about earlier how you consider h to be opposite in sign of the thing in parentheses.
Mm-hmm.
C is the value of k. So C, value of k, that's the number that's not written. So let's say there was like a plus 4. That would be your value of k.
Yeah.
So the way I had it first written, it would have a value of k. This one doesn't. So for yours, it's 0. So for D is asking about the domain. So the domain of this, and this is a simplification, it's always going from the h value to infinity. There are actually 2 cases, but it looks like this is what they're going with.
Yeah.
So the range is minus infinity to infinity.
Okay.
Always.
Right.
So in the first graphs we did, the domain was always minus infinity to infinity. Here the range is always minus infinity to infinity. And the graph also tells you that, like, you're going to go to your calculator and you'd see a graph. This one's moving left 3. You would see a graph that looks like this. And the only thing that might be confusing it, this on the top here, it goes up forever. It just takes a while. It's moving more to the right than up, but it eventually gets up to positive infinity.
Yeah. Okay.
I think that's it. So I got a 45 next.
Yes.
Anything you want me to clarify on the previous one?
No, I think we're good.
Okay. Are you using a TI 83 or an 84?
84.
84. So your 84 may have under math a log with a place where you can type in the base.
Yes, I can.
Okay, and that you should do that when you graph it here. When you graph it, you go to Y1, but then when you're in that space right there, you go back to math and then you grab the log with the base for it. Okay, so in terms of this graph looks like this. You should see something like that when you graph it. You can graph it now or later. We'll go through the same steps here. So for part A, it's asking about the asymptote. Your instructor is being intentional. This has a vertical asymptote, not a horizontal. And you set the inside part equal to 0. There's nothing to do here. You just set x equal to 0.
Yeah.
For part B, this value, whatever you get here, that is your h value.
Okay.
For C, the k value is the other number. So if I rewrite it again, it's log base 5 of x. This plus 0 on the right, that ends up being your k value. Your domain always goes from h to infinity. So you have to, you have to put that number in for h.
Okay.
And then part E, the range is always minus infinity to infinity.
Yeah.
So I'd like to kind of summarize some of these things. I think so maybe you can see the pattern between the exponential and the logarithms. Is that okay? Or do you have other things you'd like us to cover in the last few minutes?
No, we can do, that's good. That's fine.
All right. So what I mean by that is we're going to make a table here. So we have like exponentials and logarithms like this. Okay, so the first thing that you're comparing in both of these is asymptote. So the asymptote, and consider them both to have this HK, because we've been talking a lot about that. So the asymptote is always, in the exponential, it's always horizontal, and it's always y equals k. For the log, it's always vertical, and it's x equals h.
Mm-hmm.
The domain for an exponential is always minus infinity to infinity. The range for a logarithm is always minus infinity to infinity.
Okay.
The range, the domain of the log and the range of the exponential, they're the ones that are a little bit more sophisticated, but that's we'll get to those here next. So we'll go back to a log. The domain of the log in your problems was h to infinity.
Yeah.
The range in your exponentials was k to infinity. So this attempts to summarize the graphs. If you're not sure what the graph looks like, you should graph it in your calculator. And maybe graph it twice, maybe graph it, clear it out, graph it again, or come back later and check and see if it looks the same. That way, you're really confident with it.
Yeah.
All right, so if you got this down, we can talk more about transformations or some more expressions, or we can do number 4. We didn't do 4 earlier. That's another exponential graph. Up to you.
Can I check that one? Because I did it, but I want to see if I got it right.
Okay. Let's snip 4 in. All right, so part A is to figure out whether it's growth or decay. You would graph it and find that this is growth
Yeah.
because it's going up and to the right.
Mm-hmm.
B, asymptote. So this one has a horizontal. We go back to our table, and if we recognize that this is an exponential, it's a horizontal, it's y equals k. So you really want to find that hk first. The h in this problem is -2 and the k is -5. So your horizontal is y equals -5. Really
Yeah.
everything comes from that there. We just answered what h is, it's -2, k is -5. And then so domain on this one is all real numbers, minus infinity to infinity. The range though, you go back to your table here, you're like, all right, what's my range? Oh, it's k to infinity. What's my value of k? It's -5 to infinity.
Yeah.
And hopefully that's similar. Now, in terms of like getting a good graph, we didn't talk about this at all, but let me remind you of one thing here. I'm going to go back to the calculator real quick here. So what I would do is go to the table potentially. So like all of these graphs have a table. So if you hit second table, that'll give you some numbers that help you to get as reasonable as you can. They're not looking for perfect, they're looking for the right shape and then maybe a few nice values. But I would recommend maybe looking at the table if the graph isn't very helpful. Because
Yeah.
this thing looks like it crashes into the ground and actually doesn't. It actually smooths out and but doesn't look like it.
Right.
All right. Any short questions I can answer between now and for anything else you feel really uncertain about?
Maybe the number 29 where it says like rewrite it into log form.
Yes, let's do that. So let's do 29 here. Y equals 3 e to the x minus 1.
Or actually, wait, that I completely gave you the wrong one. I meant the inverse ones.
Okay. So I was going to tell you, it was like the way you do this is an inverse. So we'll just actually, this is the same as 33.
Yeah, yeah.
So you switch X and Y. Switch X and Y, and then you solve for Y.
Okay.
So it's not too bad because you know how to do most of this. What you may be unclear about is, well, how do you get a variable out of the exponent?
Yeah.
So to do that, you use ln or log base b.
Mm-hmm.
So so you take the natural log of both sides, x plus 1 over 3 equals natural log e to the y. On the right, it becomes just y. And that's what you want.
Yeah.
So on your left, that is your inverse.
Okay.
Do you want us to go through 32 or call it here?
Yeah, probably.
Okay, this will be our last question here for tonight. All right, so here we go. You switch x and y. X equals 2 log base 4 y plus 3. So you switch x and y. And you want to get to the log being isolated, so you're going to divide both sides by 2. So it's x over 2 equals log base 4 y plus 3. So this is where you want to get rid of the log base 4. You have to undo this. To do that, you're going to rewrite both sides with the base of 4. So it's 4 to the log base 4 of y plus 3. And what it does on the right is the 4 to the log base 4 cancels.
Yeah.
And then from here, you just do anything left to get y by itself. You're going to subtract 3 from both sides. So that's 4 to the x over 2 minus 3 equals y.
Mm-hmm.
Now, what I hope is you get one really similar to this. So the steps are all the same, just different numbers.
Right.
We obviously wouldn't know.
All right, that clears that up. Thank you.
Yeah, now I do, my schedule's getting pretty full here, but if you ever need a lesson outside of what's available on my website, please just text or have your dad call or whatever, email, and just let me know, hey, I need a few more lessons. I'll do my best to accommodate.
Yes, I'll definitely be trying to find time to schedule before my final. So
Yes.
yeah.
Sounds good. All right. Well, that is it for us for tonight. Thank you for letting me help you, and I'll see you next time.
Thank you.
You're welcome. Bye now.
Bye.